Okay, so today we're going to talk about the structure of the web and about information networks. So we can start off with an information network, and these are going to be slightly different than our previous types of networks that we explored in terms of social networks where we're linking people or organizations. Here we're linking pieces of information that are related to each other in some fashion. There's going to be some differences in our type of analysis that we do, but they're not major. So a lot of the previous techniques that we saw earlier in the class can still work for these information networks. So the authors define the web as an application developed to let people share information over the internet. It was created by Tim Berners-Lee during the period of 1989 to 1991. There are a lot of different definitions out there, and I don't particularly like the definition that the authors provided here in the textbook. So if you want, you can go out and look for an alternative definition. BBC has a good article on the history of its web, but really at its cold, dark heart, it's a way to create and retrieve content in the form of web pages authored with HTML and transferred via Hypertext Transfer Protocol, or HTTP, through a web browser. We still experience a lot of the web this way in terms of transferring web pages. And here we see 4 different web pages. Now, what makes this kind of interesting is the hypertext. We can connect web pages for using hyperlinks to form a graph. The nodes are the web pages and the edges are the links. And hyperlinks were a truly novel way of organizing information back in the 1990s compared to things such as indices, tables of contents, alphabetical ordering, folders, or bulletin board message systems, etc. It's been around for a while, but the web really brought it to a global audience. And basically, they allowed the author to determine how to link from their web page. A precursor to hypertext were citations, and citations allow us to credit the source for an idea. They only went backward chronologically, but we can see how the research built on earlier work. So, when you're doing a research project, you want to go back and look at the existing work, show what was good about the existing work and where were some of the weaknesses or gaps in that existing work and how you're going to add to that with your current research. There's actually a similar structure for patents, which require a lot of the same type of work or thought process that goes into producing a publishable piece of work. A patent is a new novel idea or concept. So on the web, things are evolving, so we don't move strictly backward chronologically, and the link structure on the web is going to be more similar to cross-references in an encyclopedia. And cross-references are similar to the process of free association. There are also semantic networks in which nodes literally represent concepts and the edges represent some kind of logical or perceived relationship between the concepts. You can also think about internet rabbit holes, surfing the web, or word association when it comes to this process of free association. So another precursor was the Memex, and this was from an article by Vannevar Bush, entitled As We May Think, and this was written in 1945 at the very dawn of the computer age. And basically, Bush contended that previous storage of information was linear, but consciousness itself is associative. And he came up with a hypothetical Memex protocol and associative links that function much like the modern web. Now, it probably looked like he was a prophet or at least one of those guys in old Camel cigarette advertisements that would recommend Camel cigarettes to you. But, he did have some insight, but he was also very, very strongly connected to the U.S. government research programs, such as the Office of Scientific Research and Development, and had a hand in forming the National Science Foundation. So he was actually very, very connected in. It's the same way that Ray Kurzweil seems prescient about his predictions when he was part of the in-group that was doing a lot of these things, when he sat on a lot of boards of companies and government advisory committees. It seemed like, hey, this person is a visionary, but what it is they actually know the work that's being done from a scientific standpoint. So the web originated in the early 1990s, and back then most of the pages were static, and links are primarily a navigational function to take you to a different web page. They're now a lot more complex than getting you from one page to another. For example, you may submit your assignments on La Lima. You can order pizza using links. You can upload videos and a variety of other different amazing transactions that can be done rather than just taking you from one web page to another for the consumption of information. So we can divide our links into navigational and transactional links. Now, the authors say the web is still primarily navigational, but I might dispute that. I know we do a lot of transactions nowadays. In any case, we're going to focus on the navigational aspect of things for this discussion. So one of the things about the web that's going to be different from our previous network diagrams is that it's a directed graph. And again, we're going to focus on those navigational links as opposed to the transactional ones. And the directed nature of the links makes it different from what we've looked at so far. So for our general graph definitions, two nodes are linked by a path if we can follow a sequence of edges from one to another. A graph is connected if every pair of nodes is linked by a path. And we can break up a disconnected graph into its connected components. Those are general graph definitions, not the directed graph definitions. We're going to look at the directed ones here in the next slide. So a path from a node A to node B in a directed graph is a sequence of nodes. It begins with A and ends with B. Each consecutive pair of nodes in the sequence is connected by an edge pointing in the forward direction. We say the directed graph is strongly connected if there's a path from every node to every other node. And this one's actually not strongly connected, but we can see there's a path from the node labeled University of X to the node labeled US News College Rankings. If we go to classes, networks, network, class, blog about college rankings to US News College Rankings. On the other hand, there's no path from Company Z's homepage to the U.S. News rankings, and and looking at Company Z's their structure, their component, it doesn't look like they link outside of anything beyond their own company. So again, this one's not a strongly connected graph, but there are strongly connected components within it. When a directed graph is not strongly connected, we need to think about its reachability properties. That is, which nodes are reachable from others using paths. If two nodes belong to the same component, then they can reach each other by paths. If two nodes belong to different components, then they can't reach one another. It may not be both ways. So how do we find the right notion of a strongly connected component? We say that a strongly connected component in a directed graph is a subset of nodes such that every node in the subset has a path to every other node. The subset is not part of some larger set with the property that every node can reach each other. And so our previous graph with the University of X, Company Z, and US News and World Report, here are the strongly connected components for that particular graph. So back in the late 1990s, Broder and a group of researchers wanted to look at the structure of the web in 1999. And they did that using the Alta Vista search engine, which is now defunct. You can still put Alta Vista into Google and it'll come up with Alta Vista, but it directs you to Yahoo search engine. So it may have been, that may be what Yahoo is using nowadays. But the methodology that this research group used has been replicated with Google, Wikipedia, and other ones that are still in the business. They were interested in the abstract map versus a detail one because the detail one, if you've taken the visualization class, hey, it's going to get messy very, very quickly. So we want to abstract away some of the details. So we want to combine information in order to show a reduced version of the graph. And they particularly wanted to look at the way that the pieces fit together, and they found a giant connected component with pages for universities, companies, and government websites that were all connected to one another. So that was kind of the giant component, and it was a directed component, giant component that was strongly connected. So the next step was to take the stuff in the other strongly connected components in relation to the giant ones. And they basically classified them in the following way. N were nodes that could reach the giant connected component, but cannot be reached from. So they moved into the giant connected component that were upstream. And then there were nodes that can be reached from the giant connected component, but cannot reach back into it. Those are downstream. Tendrils are the nodes reachable from in that cannot reach the giant connected component, and nodes that can reach out but can't be reached from the giant connected component. Those are the tendrils. And then finally, disconnected ones. These are nodes that would not have a path to the giant strongly connected component, even if we ignored the direction of the edges. And this brings us to Web 2.0. So we talked about the early history of it, and Web 2.0 emerged from roughly 2000 to 2009, and it was more of an attitude than a particular technology, although certain technologies drove it. Three major forces: the growth of web authoring styles that enable people to collectively create and maintain shared content. The movement of people's personal data online. So that included, services like Gmail, being able to keep a calendar online, sites like Flickr that allowed you to share photos or videos that you could post on YouTube. And so these were moved from people's personal computers to sites hosted by large companies. There was also growth of linking styles that emphasized online connections between people and not just between documents. So it brought in a lot of the social aspect of it. And a lot of companies and services that we use today were part of this Web 2.0 growth. Facebook, Gmail, Wikipedia, Twitter. And there was also the creation of reputation and trust systems, and a lot of research that went into that in the early days of electronic commerce. I might argue that electronic commerce was a big part of that as well. Anyway, that's it for now, and thanks for watching.